Okay, we'll go ahead and get started. And I have the PowerPoint open just as a reference. Last time, I did a lot of coding examples and I got a lot of thumbs up that students liked the coding examples as far as problem solving, right? So I am going to continue in that nature of problem solving. But even last time when I was doing the problem solving, there's still theory intermixed in, right? So we still hit all the objectives. We still hit the theory, we just kind of hit it in a little different way. So one thing that I always like to hit, and if you ever have sat in any of my other lectures, you've heard me say this before. It's always important to understand the big picture and why you're studying topics, right? You need to be able to zoom out and understand the why. The why, in my opinion, is always extremely important, right? And you need to be able to explain it. If you're on Reddit, and I'm a Redditor, explain it like I'm five. And so why am I studying this as if you're explaining it to a 5-year-old, right? And here's how I would do this concept of inheritance if I'm explaining it to a 5-year-old. Now, a 5-year-old who's been in my class a little bit. We learned a concept of methods, right? We learned methods. We spent a week or two learning methods. And the why behind methods was this concept of code reusability. And I think if you guys kind of think back to when we first learned methods, you might remember that. And that we even did a lecture on paper, rock, scissors, and we wrote one method that you could just call over on different button clicks. And you just call that one method, and you didn't have to have code replicated multiple times in multiple different places. Instead, you wrote the code in a method and then just called the method, right? So you didn't have to have replicated code, right? There was an acronym called DRY. Keep your code dry, meaning don't repeat yourself, okay? So the whole big picture why on methods was code reusability, right? Write some code and just reuse it. It's more efficient that way. And then after methods, we learned this new structure that you can actually put methods into another structure called a class. And a class, you instantiate a class to build an object. And so we can encompass a method in this other structure and then reuse that structure. And not only can you reuse that structure, be it a class, and that class has methods, but these classes also have data, right? And so like a student has a student ID and a student name and da. So then the next thing we got into, after we learned that, hey, methods are there for code reusability, then we got into classes and objects. And really classes contain methods. And the whole reason why we make these classes and objects is for code reusability. You make this class one time, and then you can have like a list of that thing. You can have a list of students, or you could have all of a sudden you've got 24 students in a class, and you have a list of students, and they all have the same attributes, they have the same methods. You understand how to work with the student if you understand the student class. Code reusability, right? So if I'm explaining this like I'm 5 to a 5-year-old, I'm going to the 5-year-old and I'm saying, hey, 5-year-old, methods help us, reuse our code and write code more efficiently, write our code better, okay? Classes are there for code reusability. We're making this thing and reusing it a bunch. Again, it simplifies our code. We're not repeating ourselves. If you make an error in your code, that we all make errors, you just have to fix it one time. You don't have to fix it repetitively. You just fix it in the class, and then it's fixed everywhere you use the class. Okay? So methods are there for code reusability. Classes are there for code reusability. And so we kind of rolled methods into classes, right? Well, turns out if you want to make classes more efficient, right? Start reusing bits and pieces from other classes, you have inheritance. So why does inheritance exist? Same reason. It's going to help you keep your code dry and reuse your code, right? So the same big picture. Why do methods exist? Code reusability. Why do classes exist? Code reusability. Why does inheritance exist? Code reusability. We're going to reuse our code. So it's actually a way to make our classes, we're going to code our classes now more efficiently. It's almost like this is growing. Like first you learn methods and you learn how to bundle methods into classes. And then once you learn classes, now we're going to learn how to make our classes more efficient by learning this thing called inheritance. Okay, and it's there for code reusability. It's there to help us write efficient code. And so, when it gets into inheritance, what is inheritance? And I can think of a couple kinds of inheritance outside of the coding world, and I'm sure you guys can think of the same kind. What kinds of inheritance are you familiar with in the real world that, what is inheritance to you?
Like, I guess receiving from,
Yeah.
Someone before you.
Someone before you, right? Receiving something from someone before you, like maybe and so expand on that. What might you receive?
I don't know, money.
Money.
Maybe.
Okay, so there's financial inheritance, right? Someone passes away, your great uncle passes away, and he was a millionaire. Suddenly you're a millionaire, right? Wouldn't that be nice? So there's financial inheritance. Scott? Genetics, right? These are both examples of inheritance, right? Something passed down from your parents, maybe your grandparents, maybe an aunt or uncle, but something passed down, whether it's genes or whether it's money, if you're fortunate enough. A lot of parents have the theory of I want my last check to bounce, and I kind of subscribe to that. Let me make some money in my lifetime, but let that last check bounce. Anyways, genetic inheritance. So my father was tall, right? So I assume I got my tall gene from my father, and my mother was pale-skinned. So I know I got my pale skin from my mom because my dad is tanned. Yep. My grandparents were avid walkers. So yeah, I guess, activity, whether that's a learned trait or inherited, whatever. But yeah, I could say that's inherited. Simply put, inheritance is something passed down, whether it's money or whether it's, what you're talking about, money might be a data point, right? So maybe a bank account balance could be passed down. Yeah, you see this? Your balance could be passed down. But what you also mentioned was activity levels, like maybe walking. Your activity level would be a behavior, aka a method that could be passed down. So what I'm pointing out here is that data can be passed down, aka your properties could be passed down. Behaviors like methods can be passed down. Yes.
Something that might correlate well with coding. My family likes to refer to nature versus nurture because I'm adopted.
Okay.
And my birth mom is very into Greek mythology, very pagan in her beliefs, Wiccan, and a bunch of nerdy stuff.
Yeah.
Without being raised by her, me and my sibling, who was raised by her, have basically the same personality, exactly the same interests, same hobbies.
Personality traits.
Yeah. Hobby traits,
Yeah.
the whole shebang.
Yeah.
Except
Because of who you were raised by. or not even directly raised by?
I was raised by two lovely people in Missouri.
Yeah.
They lived in New Jersey.
Huh.
Completely different environment.
So do you think that was...
Nature versus nurture.
Yeah. Interesting. Nature versus nurture.
Yeah.
Yeah, so you were nurtured into it. Is that kind of thing?
More along the lines, though, I think it was meant to be with how nature kind of.
Gotcha. Very
So I
cool.
think
Very cool.
that's- I think it could correlate well with coding because even if it's something in a different class, you can bring it into a different class
Mm-hmm.
and it still has that.
Yeah. So that's exactly what we're going to talk about here, right? We're going to have different classes, and you can kind of see this slide just shows you some of the language, right? You have a base class, which is essentially the parent, okay? And it's going to pass things down, aka the arrow, down to the child, right? And so the base class versus the derived class, okay? The parent and the child, same thing, right? Parent-child relationship, base and derived. Question?
You know how so you know how we usually go about making a class by like going and making a separate like folder, you can say, for it.
Mm-hmm.
Is this gonna work in the same way methods do, like where you have multiple methods you could like access by having multiple classes and being you can, let's say, connect them?
Yeah, we'll have multiple classes, and they'll all be, one will be inheriting from another. You'll see it in just a little bit when we get into the code and how we actually code inheritance. But yeah, essentially we'll have multiple classes. These various classes will inherit from one another. If you want to understand something, if you want to understand a child, it might help to understand the parent, right? So if you think of like in coding, you might have a class called dog, and you might have, well, above dog, you might have animal. So just very generically speaking, the higher up the inheritance chain, you get more generic things, more generic entities. The lower you get in the inheritance chain, it gets more specific. So in this example, you know, at the top, you might have animal. I guess an animal inherits, sends things down to a dog. And dog you might have a child of dog, be it, I don't know, I'm just thinking a pit bull is a type of dog. Right? So if I want to better understand a pit bull, maybe I can start by understanding what a dog is. If I want to better understand what a dog is, maybe I just have to start with an animal. And so, well, under animal as well, we could have another child called cat. Okay? So by defining that an animal has a property, a public int number of eyes, some number of eyes. If you create an animal, it might be 0, it might be 1, it might be 2, it might be 8, it might be 1,000, whatever. An animal has some number of eyes. Well, by declaring this property in this top class called animal, my cats will have a number of eyes, my dogs will have a number of eyes, and my pit bulls will have a number of eyes property. Do you see the code reuse we get here? By writing this property one time, all of the children will inherit that property. I don't have to declare a number of eyes in dog, and another number of eyes in cat, and another number of eyes in pit bull. Right? So at a high level, this is the benefit of inheritance, code reusability. And again, something that I said is as you go down the chain, as you go from top to bottom, you go from more general to more specific. right? Your classes go from more general classes down the chain to more specific, okay? And if you didn't know, C# is full of inheritance already. Like the first time you study a class, you come across a new class in C#, you begin to learn that class by studying its parents. Oh, if I know what the parent is, I can begin to understand the child, right? So when I come across, and C# is built of a lot of built-in classes. There are so many built-in classes. Yeah, I'm learning them all the time. You know, it is a huge library of code that we have barely scratched the surface of. Okay, there's a lot of built-in classes. So very frequently, it's like, hey, here's a class I've never seen before. I want to begin to learn about this class. Let me study its inheritance chain. Because if I can understand its parents and its grandparents, I can begin to understand that class itself. Okay, so this is on the slide 5, this is an inheritance chain that's kind of built into the language. There is, as this slide kind of shows, there is a class called form. There is a built into C#, there is a class called a form, and the forms that we create inherit from that parent, right? And so if you like go behind the code, you can see that inheritance taking place. Again, you have to learn how to code inheritance, but you can see that inheritance. And so some of the methods of the form class are inherited by the form that we're creating, right? So there's a method to close the form, to show the form, to have a little dialog pop-up window, right? All that code exists, right? Like, I don't know if any of you in this class have manually coded the close method, like this dot close to close the form. Maybe you have, but where did that come from? Well, that was a method that was inherited, right? That was passed down from this form class kind of automatically, right? So there was some built-in inheritance taking place. There are inheritance chains, like I started to draw on the board, chains of inheritance. Now, as we're learning about this for the first time, I think another thing worth noting, you can, different languages handle this differently, but in C#, your class can only have one parent, right? Which is obviously different than, like in the real world, obviously, you know, we all came from two parents, right? So, but in C# we just have one. C++ was like the first language that I studied, and you can have what's called multiple inheritance in C++, right? That just doesn't exist here. You have a single parent. So you're going to notice that like the form class in this here, you know, inherits from container control, which inherits from a scrollable control, which inherits from a generic control, which inherits from the generic object. You don't have to know that chain for like the test or anything like that. There is an inheritance chain. You don't have to understand every step along the way. Just understanding that there are inheritance chains, parents and grandparents and great-grandparents. That's all we're looking at here, is a family tree, if you will, of parents and blah, blah, blah. And at the top level, right, at the very top level, there's a class called object. So object is the great-grandparent of them all, right? If everything derives from one root class, that root class is object. So every C# class ultimately inherits from object. Remember what I said a little bit before. If you wanted to understand children classes, then understanding their parents makes sense. Well, so it makes sense, since everything derives from object, it makes sense to kind of look at what are the methods in object, because those are very common methods that you'll find, right, in C#. One of those methods that's built into object is a toString method. right? That should ring a bell with everybody because we have written a toString method. And there are other methods that are built into object that we will actually cover. Now it's worth mentioning, right, that these methods that are in the object class oftentimes need to be overridden to give them a specific purpose, right? So when you're making your own student class and you create a student object from that student class, what's the generic output for a student? Like, what data do you want to come out of a student object? When you're creating a student object and it's got all these properties and all these methods, like, what's the generic output that you want for a student? Well, that's really ambiguous.
Name.
Maybe you want the name, maybe you want the ID, maybe you want the income levels, who knows, right? It's really up to the developer to decide the standard output of an object. Okay, it's up to the developer, aka it's up to the decision makers of the software. Okay, but that's the purpose of toString. The toString is kind of like your default output. Well, there's a lot of other methods, like the equals methods. Well, if I'm making a student class, how do I determine if two of these students are equal? I don't know. Like, are they the same student? Maybe by their social security number? If they have the same social security number, then the two students are equal. Maybe? But the point is, these methods that we're looking at here, they're all inherited automatically from all the classes that we're creating. Again, our classes that we're creating, be it students or bank accounts or what other classes have we created? Hockey players or computers or whatever. They have these methods automatically because our classes inherit from object. Automatically. Object. Every class inherits from object, therefore all of our classes have these methods. Unfortunately, they just don't have much purpose unless we give them purpose. It's like you could call a toString method, and you know what it's going to return? Like if I have a student class, if I have a student class, and I don't code a toString, and then I call the toString method because it's a method there that you can call, it just returns the namespace dot class name. It's like really not useful. It's really not useful information. So all of these methods will give you some sort of default implementation, but they're not useful. You have to give them a purpose. But these are common methods that you want to give a purpose. Okay? If I'm coding a new class, right, for the first time, and maybe one of you coded it, it's pretty conventional for your classes to have an implementation of toString. It's conventional to find that. So as a user of a class that someone else wrote, I might call a toString method expecting some relevant information to come back. Okay, so the takeaway here, these methods are inherited. We get them for free. They don't have much use. We have to implement the methods. And like we did, we've already done this once. You had to override. Remember that keyword, override? Like there is a default implementation, but it's just not that useful. We have to override that implementation. Right? So we did that on toString. Okay, and so, you can have classes that inherit from parents. Again, single inheritance. You can't have multiple parents. So both the children, book and software, can inherit from product. Now there's one thing that I haven't mentioned is that we've talked about access modifiers a little bit. Access modifiers are private and public. Those are the main ones we've talked about. There's going to be a new one in this chapter called protected that we're going to be introducing. So the children basically inherit the non-private members. Okay? A member, when I use that language, realize a members is either a method or property. I guess you could also say a field, like an instance field could be a member, right? So children inherit from parents. Do they inherit everything? Well, it's kind of like ultimately someday, everyone dies. Our parents will ultimately die. Do you get everything in the inheritance? You don't get everything. A lot of times that's kind of split, whatever. Maybe you do get everything. Point is, do you get everything? And in this inheritance, in other words, does dog inherit everything from animal? The answer is no. It doesn't inherit everything from animal. It inherits everything that's not private. So it inherits public things, public members, and things that don't have access modifiers, right? So for the most part, we're going to put access modifiers on everything, okay? But it does not inherit private, and there's a new one called protected that it would also inherit as well. Yes.
So is there no way to access anything that's private?
Good question. You can still access the private fields through the public members. Okay, so that's a little weird. If you have an instance field that's marked as private, and then you've got a property that works with that instance field, right? The child will inherit the property because it's a public property, and it can work with that private field through the public property. Okay, so it's a little tricky because it actually can work with private members through the interface, if you will, through the public property interface. Okay, that's actually a really good question. I'm glad you asked that. Okay, so, here's a class. It has 4 public members, right? We've got 3 properties and we've got a method. That's called product. Remember, product has some children. Children being book and software. So, of course, here's book. Okay, here's book. And I'm going to do a little problem solving after this because I see I'm losing people's attention. This is for the first minute of actually how do you inherit things in code, right? If you understand about inheritance and why inheritance exists, code reusability, then you can begin to understand, why the benefit's there, but how do you do it, right? Why is actually more important than how because the how is different in every language, but inheritance is in every object-oriented language, okay? I first studied inheritance in Java, and it's here in C#. It's the same deal, okay? So why is more important than how? This is the how. You can see public class book. Book is the child. Remember, book is the child per this diagram. Book is the child. Product is the parent. So you create the class called book. You put a colon there. Where's my book class? There's my book class. Public class book, that's your child or your derived class, as they also call it. Colon product is actually pretty simple. You just put a colon there, and then you give the parent class, aka the base class, after after the child. And now book automatically gets what there were 3 properties and there was 1 method. So there were 4 members. 4 things are now passed down so that we can create a book, and that book gets those 4 things for free through inheritance. Okay, so if I kind of jump back up, what were one of those 4 things? Like a product has a price, right? Product has a price. I can inherit book. Now, somewhere in here, we're going to create a book and take a look. The book has a price of $59.50. Been reading too much Dr. Seuss. Just because I made one little rhyme, but man, there's moving on.
Those books stick with you.
They stick with you. Green Eggs and Ham, I've read it 100 times in the last year.
One fish, two fish.
1 fish, 2 fish, red fish, blue fish, yeah.
Get to just wait until you have to start reading the one to teach people.
Cat in the Hat. I never read Cat in the Hat until I was 40 years old. I've now read Cat in the Hat.
Deals with
you ever seen
difference
the
in
movies?
race.
No?
Like
There's a Cat in the Hat movie?
Yeah, and he's like a giant cat.
Is it any good?
It's not something to watch with a kid.
Yeah, it's kind of.
Who is?
Michael Myers is the.
Okay.
It's not something to watch with a kid.
Yeah, I can't remember if it was
All
like
right,
a dirty movie
all right,
or not.
all right.
Is it a dirty movie?
It's no, it's. It was.
It's amazing how to wake up a programming class. whatever it takes.
It did show on Cartoon Network, but it showed later at night. It's like a TV 14 kind of movie.
It was so bad that Dr. Seuss's widow disallowed any Hollywood studio to make another live-action Dr. Seuss movie.
Yeah, but it was one of those good.
What was the Rotten Tomatoes?
But let's find that out. I'm gonna look it up.
Michael Myers.
That movie went hard.
Oh, you meant the website.
What's the name of the- oh, the kid called the
Ooh, 10%.
2003. That's the one I'm talking about.
The audience score is a
10% on Rotten Tomatoes.
10%.
That's the
10%.
critic score. Audience score gave it a solid 56.
Ah.
I remember watching it at school or something, and I thought it was pretty good. Probably
The
like it.
critics.
You would have been on the 56% side versus the
There's
44%.
toilet humor and double entendres. If you just want to brain dead comedy, it's good.
I remember it kind of being creepy.
All right, let's take a look at a problem and continue, because now that we've got some of the theory out of the way, we can begin to implement inheritance with some word problems. And so let's take a look at a word problem. Create an application named Letter Demo that instantiates objects of 2 classes named Letter and Certified Letter. So letter is going to be the parent, certified letter. Oh, one big thing. You know, in the real world, we use English to describe, to communicate and to describe problems. And so in the software engineering space, when you're taking a real world problem and you're writing it down and you say, I want to solve this problem with software, right? You often start with a written description of the problem. So if Ben comes to me and says, hey, I want to build this software, I'm going to say, Ben, write all that down. I want you to write down what you want the software to do. Okay, so you start with a problem description or an opportunity description, a problem domain. You start with the written word in English. And oftentimes the written word, you're going to see language like, has a class has a bunch of students, right? So a class object has a list of students. And so in the English word, you can begin to start to break down English and translate that into code, okay? And so in inheritance, the breakdown is always based on what things are. And so in inheritance, the whole inheritance structure is based on what things are. And when you say one thing is another thing, a dog is an animal. Okay, in the English language, is a translates into inheritance in code. And so when you see things like a certified letter is a letter, even though that's not how it's written here, that implies inheritance. Okay, so just, anytime you study inheritance, you're going to study that inheritance is called an is a relationship. It's an is a, in quotes, is a relationship. Okay, so that's a little bit more theory there. Okay, so we've got two classes, letter and certified. Okay, the classes are used to keep track of letters they mail. The letter class includes auto-implemented properties for the name and recipient and the date mailed. Okay, so we've got three auto-implemented properties for letter, and since we have a date mailed and we were working with date and time, we're going to continue with that. So here's my inheritance demo. I'm going to start by adding a class. This is going to be the parent class called letter. We're going to mark it as public. It's going to have three auto-implemented properties. The first one for recipient. Recipient would be someone's name, so let's go string, capital R, ECIP, IENT, enter. We have a name of the recipient. Oh, did I say three? It looks like two. And the date mailed. So we'll do prop, tab. We got, let's experiment with date only. So we got a date only called date mailed, and save that. Just a little one-off. If you create a letter, there's you can say that if you ever create a recipient, you create a letter, by default the recipients should be null. Then you get this little cannot convert. So cannot convert null literal to a non-nullable reference type. Your data types can be nullable. Strings should be nullable. But if you ever want to make a type nullable, you might see this quite a bit in the future, where you make your types nullable. In other words, like integers for sure are not nullable by default. And if you want to make an integer nullable, so like int value equals null, right? You make a type nullable by putting a question mark in front of it, right? So this is not something that's necessarily related to inheritance, but it is something you'll see. So I just wanted to show you that you can make a type nullable by adding this question mark and a default value kind of here. Okay, not important for this discussion, just something in C# you'll see. So here's our class called letter. It has a recipient and a date mailed. But also include a toString method that overrides the toString method and returns a string that contains the name of the class and the letter's data field values. So we are going to include a toString method, public override toString. Now you understand where toString comes from. ToString comes from object. Object is the parent of letter. Okay? Automatically or implicitly, there is this on all of the classes that we create, right? Automatically, our classes inherit from object. Now, we don't have to code that. We get that for free. Okay? But that's where ToString comes from. Because ToString kind of has a default implementation, we have to override it. We say we don't want to use the default implementation. We have to override it. And we're going to return a interpolated string that says now it says using the get type. Get type is a method that you do get for free. And get type just returns the name of the class, and it might even return the name of the namespace. We'll see how this plays out, because I think it is namespace.class. or it's just class. We're going to see, but I wanted to say the letter has a recipient of, we're going to call the recipient property, and a date mailed of date mailed. Now I want to set the default to date only dot see, if I had a date time, I could do, let me look at these properties. I'm a little bit less familiar with this one. Max value, min value, try parse. Okay, I'm gonna do a public date time. Just more familiar with that. And that was called date mailed. Get set, and the default to date time dot now. It kind of has like a default date time if you don't set it. All right. And we've overridden the toString. Now notice I haven't built a constructor, but I do have some auto implemented properties. So I'm going to use object initializers to put the data in. Now let's continue with the problem. Create a child class named certified letter that includes an auto implemented property that holds a tracking number. Okay, so, all right. Here's my parent class called letter. I'm going to make a child class, add class, certified letter. Certified letter is the child, inherits from letter. Now let's make this a public class, certified letter. And again, we are inheriting the non-private members. Well, there's 3 of them. There's 3 members that are non-private. We've got 3 public members here. Okay, 2 of them are auto-implemented properties. 1 of them is a toString method. We get all of that. Now, check this out. We're going to add a tracking number. Well, I don't know. I guess that's a string, right? Prop, tab, string, tab, tracking number. I'll make this a nullable string. Should be nullable, whatever, equals null by default. And I'm also going to override. Now when I override toString, now I'm actually overriding the parent's toString. Now check this out. See that base toString? Line 15? I want to use that. That's going to call letters toString. So it's going to call letter toString. And I'm going to add the tracking number is. So this is an interesting way of getting some code reusability. This is gonna, if I create a certified letter, the certified letter is gonna spit out the type and the recipient and the date mailed and the tracking number. Okay, if I call a certified letter toString. Okay, so base toString calls the toString of the base, which is the parent. Right? Remember, base class is the parent, derived class is the child. Okay, so very simply, let's demonstrate this by creating both a letter and a certified letter. Create a big button that says create letter. And copy, paste that button. Copy, come on Visual Studio. Create. Okay, create letter, create certified letter, and the name. Even when you sort alphabetically, the name goes up at the top. That's fine. button create
Because it's next to
letter.
parentheses.
because it's in parentheses. Good eye. And this is button create certified. That's fine. So here's my button create letter. I'll say letter L1 is new letter. And just to kind of show you, well, let's just do this. Let's just create a, what do we have? A recipient. Recipient equals Bob. And date mailed equals, now if I have a string, okay, if I were to just say like 3/13/23, that's not going to compile because we've got a date time object on the left, we've got a string on the right. Thankfully you can parse this into you can convert this date time dot parse. You can parse a string into a date time object with this method. So this is just how you convert a string into a date time object. Also, I want to show you this. My date mailed has a method to string date mailed is a date time. Hold on. Okay. There's a method to short date string I'm not seeing there. Let's just see how date mailed comes out. So we're putting date mailed in one way. All right, we're creating our object. Our object has a recipient and a date mailed. And then we're going to spit it out in a label. So here's our label. Properties called label results. Clear out that text. And now I'll say label results dot text is L12 string. Okay. And so this is my toString method of my letter class. Again, it is the namespace, I would say the project dot class name. That's what the lab calls for. That's the result you get. If you call get type, that's what you get. Has a recipient of Bob and the date mailed of 3/13, which is what I kind of hard coded right here. Okay, so data's going in just fine. I'm bummed that my date time methods aren't coming up. There's a date time to, let me pause this real quick. Look this up real quick. Okay, so my method was there when I made the type non-nullable. That was, if I during the recording, you might notice I dropped off my question mark on line 12. Now my date mail to short date string, that's the method I was looking for. Now we just get the date back. We don't need that time period portion. Okay, so that's a letter. Now, question so far? Yes.
When I run this, it shows up as has recipient Bob and a date time.
Okay, now let's take a look at the inheritance at work. So I'm going to create my certified letter. Here's my certified letter. Certified letter is a letter that also has a tracking number. I'm going down the inheritance chain. It's going to get everything from the parent, the non-private fields, and it's going to have a tracking number. So check this out. If I go into create certified and I say certified letter C1 equals new certified letter. Now notice I can also set a recipient. That's being inherited, right? Recipient is Tim. The date mailed is date time.parse, throw in a string of today, 3/14/23. And I've got a tracking number, which is a string 1A to B. Okay, let me kind of format this so you can see it. Put a semicolon right there. And you can even break that up like that. Okay, we are creating a certified letter object. You get the properties from the parent, and you get the additional, more specific properties of the child. And if I grab my label result to string, it's a certified letter to string. Remember, certified letter calls the base to string and adds the tracking number. So if I create the certified letter, now notice my type, the inheritance demo.certified letter. It knows what type it was. Was it a letter or a certified letter? Get type obviously knows what type the class is. Has a recipient of Tim, and a date mailed of, well, this is today, and a tracking number. Right? So we have reused the code of letter in certified letter to make a more specific child. And we have demonstrated inheritance, and we've completed the first word problem. Okay? I'm going to kind of stop. I'm going to send you guys on break. We're going to do another word problem when we get back.